Welcome to Deep Dive into Knowledge.
The shocking secrets behind cave formation.
Welcome to Deep Dive into Knowledge. I want you to, just stop for a moment and picture this. You step over a line, just a simple threshold in the earth, and suddenly the world you know completely disappears.
It just vanishes.
Exactly. The sunlight simply vanishes, the sound of the wind dies away, and you are surrounded by a silence so ancient and so deep that it actually feels heavy pressing against your ears. You aren't just walking into a hole in the ground, you're crossing a boundary into the deepest memory of our planet. Today, we're asking you to step into the dark with us.
We want to take a slow, quiet look at a phenomenon that has, I suppose, captivated human imagination since the very beginning of our species.
Think back to the Stone Age. Finding a cavern wasn't just an interesting geographical discovery, was it? It was quite literally salvation. These spaces offered a strong stone shield against the biting cold and the predatory beasts that roamed the wild. But over time, that purely physical protection took on a profound spiritual weight.
It really did. The ancient Greeks, for instance, believed their most powerful gods, like Zeus and Pluto, actually dwelled within these subterranean depths. The Romans, looking into the shadows, imagined nymphs and spirits lurking just beyond the reach of their torches.
There's this deep-rooted, almost instinctual reverence we hold for these spaces. You can feel it even today.
Yes, and it's a reverence that makes perfect sense when you consider how we usually interact with stone. Today, we often visit majestic, human-carved wonders places like the Ellora Caves in India, and we marvel at the sheer genius and determination of the people who shaped them. But there's a deeper, much older story here, and it lies not in the carvings, but within the uncarved rock itself.
If we pause and look beyond the human element for a moment, we begin to witness this terrifyingly quiet, epic battle between two of the simplest elements on Earth, rock and water.
That's the core of it. The birth of a natural cavern isn't a violent explosion. It's a patient, slow-motion war that leaves behind voids large enough to swallow skyscrapers. It's a story of persistence that really forces us to redefine our entire understanding of time.
That concept of a slow-motion war is exactly what we need to unpack today. Because when we think of water affecting rock, our minds usually go straight to a river wearing away a canyon, right? We picture rough, physical scraping.
Rushing rapids carrying sediment that sands down the riverbed.
Exactly, the physical friction of it. But the true nature of this underground erosion, the process that creates the world's grandest subterranean labyrinths, is actually something entirely different.
It is entirely different. The vast majority of the grandest underground systems are what we call solution caves, which are also known as limestone or karst caves. And the mechanism behind their creation is primarily a chemical reaction rather than a physical one.
So it's not water punching the rock, it's chemistry.
Precisely. To truly understand how this works, we have to look closely at the rock itself. Limestone is predominantly composed of a mineral called calcium carbonate. Now, in the grand scheme of geology, it's a relatively soft rock. But more importantly, it has one fatal inherent flaw.
It dissolves.
It dissolves when it's exposed to a specific, very weak acid. For a long time, the conventional wisdom was simply that underground rivers washed the stone away over time. But the modern, much more fascinating truth is that the very air we breathe is what arms the water, turning it slightly acidic enough to essentially melt the solid stone away.
It's basically a massive chemical conspiracy happening right under our feet. But how exactly does water acquire this hidden weapon? What's the step-by-step process that turns a gentle, unassuming rain shower into something that can literally consume a mountain from the inside out?
It all begins high up in the atmosphere. When a drop of rain falls through the sky, it absorbs carbon dioxide gas from the air around it. It's a very subtle interaction, but a crucial first step. So you have this slightly carbonated water, not unlike mild sparkling water, falling to the earth.
Right, so the rain is already armed, in a way, before it even touches the grass.
It is, but the real transformation happens next. When it finally hits the ground and begins to seep into the soil, it encounters a completely different environment. The soil is packed with dead leaves, decaying plant matter, and complex root systems. All of this biological decay releases a tremendous amount of carbon dioxide into the soil.
Much more than is just sitting in the open air.
Exponentially more. So as the water trickles through, it grabs even more of this gas, and as it percolates downward, it transforms into a weak liquid known as carbonic acid. This mild acid is the silent destroyer of stone. When it eventually seeps deep enough and hits a hairline crack in the limestone bedrock, it chemically reacts with that calcium carbonate.
It doesn't just push the rock away.
No, it literally dissolves the solid rock, turning it into a soluble liquid solution, which simply flows away with the underground currents.
I think the sheer patience required for this process is what's most staggering to consider. We're talking about an action so incredibly slow that it's completely imperceptible to a human observer. It takes hundreds of thousands of years just to hollow out a space large enough for a person to crawl through on their hands and knees.
That patience is the defining characteristic of geological time. The acid is entirely opportunistic. It always follows the path of least resistance. As it slowly dissolves the rock along a tiny fracture, that crack inevitably grows wider.
And then a wider crack lets more water in.
Exactly. A wider crack allows a greater volume of water to rush through, which in turn brings more carbonic acid, which dissolves even more rock. It's a geological domino effect. Over millennia, this self-amplifying process builds those vast, twisting underground networks we eventually discover.
It's just a relentless creeping expansion.
It is. However, recent scientific observation has added a really fascinating nuance to this timeline. We're now looking closely at the hydrology of severe storms. While that slow, constant trickle does the foundational work over thousands of years, it's the sudden, massive influx of water during heavy rain events that acts as a vital flushing mechanism.
Wait, so the storms are actually cleaning out the caves? Like flushing a pipe?
That's a perfect analogy. These rapid flows quickly sweep away the dissolved material. If the water just sat there, it would become completely saturated with calcium carbonate, and the chemical reaction would simply stall.
The melting would just stop because the water couldn't hold any more rock.
Precisely. So the fast water clears the pipes, allowing fresh acidic water to resume the work. This tells us that these enormous, wide-open caverns likely grow much faster during periods of extreme surface weather than a slow trickle ever could manage on its own.
So it's this cycle of quiet, persistent chemistry, punctuated by sudden, violent flushes of stormwater. That's a remarkable cycle of destruction. But what I find equally beautiful is the aftermath of all that destruction. Because once the void is created, the water doesn't just vanish. When that mineral-rich water finally drips from the ceiling into an air-filled chamber, a total reversal of the chemical process occurs.
Creating those incredible formations we call cave jewels.
Yes, exactly.
The formations collectively known as speleothems. It's a beautiful piece of chemistry. When a drop of water hangs in the air of the cavern, it suddenly finds itself in an environment with much lower carbon dioxide levels than the rich soil it came from up above.
Because it's suddenly in an open, airy cave rather than buried under decaying leaves.
Right, and because of this steep gradient, the carbon dioxide gas literally escapes from the water drop and diffuses into the cave air. And the moment it loses that carbon dioxide, the water can no longer hold the dissolved rock in its liquid state.
It has to drop its cargo.
Exactly. The calcium carbonate instantly solidifies, precipitating out of the water to form microscopic crystals on the rock surface.
And over centuries, those microscopic crystals stack up to build the breathtaking structures we see in photographs. And just for anyone listening who always gets them confused, there's a charming old memory aid for keeping them straight. The stalactites hang tight to the ceiling, while the stalagmites are the ones that might eventually reach the top from the floor.
And a brilliant little rule of thumb.
Thinking about their growth rate really humbles our perception of time, doesn't it? If I'm not mistaken, they can grow as slowly as 1 single centimeter over an entire century. They are quite literally the crystallized record of time passing.
They absolutely are. It's geology functioning as a slow-ticking clock. But while solution caves are certainly the largest and most common types of caverns, they aren't the only way nature carves out the earth. That slow, meticulous chemical dissolve is deeply contrasted by the furious, rapid formation of volcanic chambers.
The lava tubes? That's a huge contrast. I mean, if it takes 100 millennia just to melt out a crawl space in limestone, how do these volcanic structures defy that timeline? It seems almost contradictory that a cavern of any real size could be born in a matter of days or weeks.
It all comes down to the thermal dynamics of flowing lava. It's entirely different from water. When a volcano erupts and a river of molten rock flows across the landscape, the surface of that lava is naturally exposed to the much cooler atmospheric air.
Which chills it immediately.
Right. This exposure causes the top layer to rapidly cool and harden, forming a solid, insulating crust over the river. However, beneath that newly formed crust, the core of the lava flow remains incredibly hot and fluid. It continues to flow downstream, perfectly insulated from the cold air above by its own hardened roof.
So you have a river of fire running through a rock tunnel of its own making.
Exactly. And when the eruption eventually subsides and the source of the lava stops pumping, that underground river of molten rock simply drains away down the slope, leaving behind the empty, hollowed-out channel. That pipe-like structure that remains is the lava tube.
It's fascinating to think about these structures not just as relics of past eruptions, but as potential keys to the future of humanity. Because as we look towards the stars, these volcanic tubes offer something incredibly valuable.
They offer a pre-built sanctuary.
They really do. If we ever establish settlements on the Moon or Mars, both of which have ancient, dormant volcanic landscapes, these natural structures could provide ready-made protection. They offer an immense natural shield against the harsh cosmic radiation and the lethal extreme temperature fluctuations you find on those celestial bodies.
It's a very pragmatic view of geology, but a highly accurate one. We're essentially looking at natural bunkers that require absolutely no construction materials to be transported from Earth. You just find an opening and move in.
It saves us shipping steel to Mars.
Quite. But returning to our own planet, there's another completely different mechanism of cavern formation found right along our coasts. The sea cave. Unlike the chemical dissolution of limestone or the thermal draining of lava, the creation of a coastal cavern is a pure story of brute mechanical force.
Right, so sea caves are less about elegant chemistry and more about just relentless pounding energy from the ocean. It's physical scraping and tearing.
Exactly. You have the constant, powerful smash of ocean waves against the coastal cliffs. But it's not just the water doing the punching. The waves carry sand, pebbles, and even larger rocks, effectively turning the water into a massive, grinding abrasive. It mechanically carves away the weaker sections of the cliff face.
Like liquid sandpaper.
Very aggressive sandpaper, yes. But there's another, perhaps more fascinating invisible force at play here: pneumatic pressure.
Wait, pneumatic, like trapped air?
Precisely. As a massive wave crashes against a solid rock face, it forces water violently into the naturally occurring cracks and fissures. In doing so, it traps the air that was already resting inside the crack and compresses it under immense pressure.
It squeezes the air into a corner.
Yes, and when the wave inevitably recedes and pulls back into the ocean, the weight of the water is suddenly removed. That trapped, highly compressed air expands instantaneously. It acts like a tiny, localized explosion deep within the rock.
So the rock is being blasted from the inside out.
That's right. This sudden expansion widens the crack, weakens the surrounding stone, and over thousands of years, this relentless hydraulic and pneumatic hammering completely hollows out the solid cliff.
That is wild. It's not just the water hitting the rock, it's the water turning the air itself into a bomb. It's a symphony of destructive forces. And then, standing in stark contrast to the heavy permanence of rock, we have the Ice Age relics, the glacier caves.
A completely different environment.
These are carved by meltwater running through or underneath massive bodies of glacial ice. They hold this deep blue, almost magical beauty, but they are entirely temporary wonders, aren't they?
They are completely ephemeral by their very nature. Because they're formed within moving, melting ice, their architecture is never static. A glacier cave you explore one summer might be completely unrecognizable or even gone the next.
They just melt away.
They're constantly shifting, growing, collapsing, and reforming as the seasons change and the global climate shifts. They serve as a profound testament to the sculpting power of frozen water, a reminder that even the most solid-seeming structures in nature are in a state of perpetual transition.
Transition in scale. Whenever we ponder the sheer size and depth of these hidden networks on Earth, it is truly staggering. We know that scientists estimate only a tiny fraction of the world's subterranean systems have ever been fully explored and mapped. It makes you wonder about the absolute extremes of this hidden world.
The extremes are continually being redefined as our exploration technology and techniques improve. If we look at the deepest dive into the Earth, we have to turn to the Arabica region of Abkhazia in Georgia. For a long time, the Arabica cave itself held the record, but modern exploration has pushed the limits even further down in recent years.
Right into the unknown.
Exactly. The current deepest known point on Earth is Veryovkina Cave, located right in that same rugged region.
And the depth of that place is almost difficult to comprehend. It reaches down 7,257 feet, which is 2,212 meters. Plunging into an environment like that isn't just a weekend hike.
Not at all.
It requires weeks of highly technical descent. It's not casual exploration. It requires specialized life support equipment, almost akin to an astronaut preparing for the vacuum of space, simply to survive the journey down to the heart of the Earth.
It is an environment completely hostile to human biology. You're dealing with immense cold, darkness, and the constant threat of flooding. But depth is only one axis of extreme scale. If we look at lateral scale, the sheer distance a system covers horizontally, the champion remains undisputed.
Mammoth Cave in Kentucky, America.
That's the one. It's currently mapped at an astonishing 426 miles, or 686 kilometers.
Think about that for a second. 426 miles. You could drive for hours on a motorway at top speed and not cover that distance, yet that is a single, interconnected labyrinth winding back and forth beneath the soil of one state.
It's an entire hidden geography.
And the most thrilling part is that the search continues. Explorers firmly believe the system is vastly larger, with countless connections waiting in the dark to be discovered.
It really highlights how much of our own planet remains completely alien to us. We map the surface from satellites, but the underground is still a frontier. But while water slowly dissolves hundreds of miles of limestone, we should also reflect on how humans have interacted with much less yielding stone. You mentioned the Ellora caves earlier, alongside Ajanta in India.
Yes, the temples carved straight into the cliffs.
The cultural and spiritual importance of these sites is immense, but the geological canvas they are set upon makes them even more remarkable.
Absolutely. The rock-cut architecture, the delicate sculptures, the ancient paintings, they are breathtaking. But we have to remember what they are carved into. These were not formed in soft, easily dissolved limestone. They were meticulously carved into incredibly tough volcanic basalt rock.
And basalt is notoriously difficult to work with. It's incredibly dense. The creation of these temples relied entirely on human ingenuity, chiseling directly into a sheer, pre-existing cliff face.
By hand.
Entirely by hand. When you consider the immense effort, the precise engineering, and the sheer willpower required to manually sculpt massive, intricate structures out of such hard rock and over a period spanning 1,000 years, it stands as one of the greatest engineering feats in human history.
It really does.
It provides a really beautiful contrast. What water achieves effortlessly over 1 million years through patient chemistry, humanity achieved through millennium of sheer physical determination.
It's a profound juxtaposition. But moving away from the human element for a moment, I want to guide our attention back to the natural voids. Because if the formation of these spaces is an epic story of chemistry and geology, the life that actually exists inside them is an even more profound tale of survival.
Biology in the extreme.
Exactly. Let's imagine stepping beyond the twilight zone, past the reach of any sunlight at all. You enter a truly alien world below.
It is an ecology of perpetual darkness. The environmental conditions down there are incredibly stable, but incredibly harsh. You have an atmosphere of nearly 100% humidity, absolute zero light, and a temperature that practically never fluctuates, day or night, summer or winter.
A complete sensory deprivation tank.
It is the very definition of sensory monotony. Yet, in this oppressive stillness, a highly specialized community of life manages to thrive.
The troglobites. They are the true evolutionary marvels of the deep. When you exist in a world of permanent night, certain biological features become completely redundant. I mean, why expend precious metabolic energy growing and maintaining complex organs like eyes when there isn't a single photon of light to process?
That's a waste of energy.
So basically, if you live in the dark long enough, evolution decides eyes are simply too expensive to keep on the payroll.
That's a perfect way to put it. Evolution is utterly ruthless with inefficiency. Troglobites, which include specialized species of cave fish, crickets, and salamanders, have completely shed useless traits. They are entirely eyeless.
We just don't grow them anymore.
They don't. Furthermore, they're often pale white or translucent. Producing pigmentation usually protects surface animals from solar radiation or provides camouflage against predators, but down there, color serves absolutely no purpose in the pitch black.
But nature always compensates, doesn't it? In exchange for sight, these creatures have hyper-developed their other senses to an almost supernatural degree. They possess enormous, highly articulated antennae and incredibly sensitive sensory hairs spread across their bodies.
Feeling their way through the dark.
Yes. They navigate the crushing darkness by sensing the faintest changes in air pressure or the absolute tiniest vibrations in the water caused by a struggling insect miles away. Their entire perception of the universe is built on touch and chemical signatures.
It's a masterclass in adaptation. But that brings us to the most fundamental question of biology, energy. On the surface of the Earth, the entire food web is predicated on the sun. Plants capture solar energy, herbivores eat the plants, carnivores eat the herbivores. Without the sun to kickstart that chain, how does this subterranean ecosystem sustain itself?
The answer is that they are deeply reliant on imported energy. The energy must come from the surface world, and it arises in two primary forms. The first is simply surface runoff. When it rains, water washes in organic debris. Dead leaves, tiny fragments of wood, perhaps an unfortunate insect that fell into a stream and got swept underground.
It's a meager diet, but it sustains the lowest levels of the web. And the second, which is often the most critical energy source for the larger cavern systems, is guano, bat droppings.
The bats are the commuters of the cave world.
That's right. Massive colonies of bats, sometimes numbered in the millions, use the caves for shelter during the day. Every single night, they fly out into the surface world, consume vast quantities of insects, and then return to the deep. They leave behind towering mounds of nutrient-rich guano on the cave floor.
Bringing the energy of the sun down into the dark.
Exactly. This waste material becomes the fertile soil of the cavern, supporting a complex web of fungi, bacteria, beetles, and eventually the larger troglodytes. The entire ecosystem is tethered to the bats' nightly harvest of the surface world.
It's a delicate, fascinating dependency. We're essentially looking at a food chain running on recycled surface sunlight. However, there's a paradigm-shifting discovery that completely upends that rule. In the deepest, most isolated, water-filled caverns, scientists have found life that bypasses the surface entirely.
Yes, the discovery of chemosynthesis in these environments has radically altered our understanding of biology. In these deep, anoxic waters.
Wait, just to clarify for everyone, anoxic means waters with absolutely zero oxygen, right?
Exactly. Environments completely devoid of dissolved oxygen. In these extreme depths, researchers discovered certain strains of bacteria that do not require sunlight, nor do they rely on imported organic matter like leaves or guano.
So they aren't waiting for anything to wash down from above.
They don't need to.
Yeah.
Instead, they create their own food by breaking down inorganic chemicals found within the rock and the water itself, most notably hydrogen sulfide.
So they're quite literally eating the rock. This means that these organisms belong to a truly independent ecosystem. They're essentially living on an alien planet right here on Earth, thriving purely on the geothermal and chemical energy of the Earth's interior.
The implications of this are staggering. For centuries, biology taught that life was a surface phenomenon, entirely dependent on a nearby star. Chemosynthesis proves that life can flourish in complete isolation, driven by the planetary engine itself.
It fundamentally changes our parameters for astrobiology, doesn't it?
It absolutely does. When we look at the ice moons of Jupiter or Saturn, like Europa or Enceladus, where deep oceans of liquid water exist beneath miles of solid ice, we no longer need to look for sunlight to hope for life. The dark, chemical-rich depths of our own planet prove that life finds a way.
It's a beautiful thought, that looking deep into the Earth gives us the exact blueprint for looking out into the stars. But these cave systems aren't just biological wonders. They're also crucial archives of the past. Let's look again at those stalagmites and stalactites we discussed earlier. They aren't simply beautiful crystals to admire. They're flawless year-by-year climate records.
Acting as a hidden thermostat of the planet's entire history.
They really are.
They are deeply analogous to the rings of a tree, but on a much grander temporal scale. Because these formations grow in microscopic layers over thousands of years, the chemical composition of each individual layer is directly dictated by the climate conditions on the surface at the precise moment that specific drop of water fell.
So it's basically nature's own hard drive. We're reading climate data off an undergrain icicle. But how exactly do scientists read this record?
By taking a core sample, essentially drilling a thin cylinder very carefully out of a stalagmite. Scientists can analyze the specific isotopes of oxygen and carbon trapped within the calcium carbonate matrix. For instance, the ratio of heavier oxygen isotopes, like oxygen-18, to lighter ones like oxygen-16, is incredibly sensitive to surface temperature and rainfall amounts.
So they can look at a layer from 50,000 years ago and know exactly what the weather was like above ground.
Down to the season. By precisely measuring these isotopes layer by layer, researchers can reconstruct the exact temperature fluctuations and precipitation patterns that existed outside the cave, sometimes reaching back hundreds of thousands of years. It provides a level of detail and accuracy regarding Earth's paleoclimate that is simply unmatched by other methods.
It's vital data for understanding the natural cycles of our planet. However, it brings us to a rather tragic reality. These systems, which have survived intact for millennia, are incredibly vulnerable to modern surface activity. The hidden world is under direct, immediate threat.
It's a crisis of connectivity. The very mechanism that creates the cave in the first place, the fissures and cracks that allow water to percolate downward, also acts as a rapid unfiltered transit system for surface pollutants.
It channels the danger right down into the dark.
Precisely. When agricultural pesticides, heavy industrial waste, or untreated sewage are released on the surface, they don't just remain there. They are washed into these deep aquifers, contaminating entire interconnected systems. Because the troglodyte ecosystems are so highly specialized and isolated, they have zero resilience to chemical shocks.
They have no defense mechanisms.
None at all. A single pollution event can wipe out an entire unique evolutionary branch that took millions of years to develop.
And beyond the chemical threat, there's the physical removal of the water itself, the global water table crisis.
Yeah. Across the globe, we are seeing massive, unregulated pumping of groundwater to support intensive agriculture and rapidly expanding urban centers. We are draining the aquifers far faster than rain can ever replenish them.
We're pulling out the very foundation of the caves.
Yes, exactly. Since the continued life, growth, and biology of a cavern depend entirely on the steady flow of water, lowering the water table effectively stops the heart of the system. It halts the natural geological processes, dries up the delicate crystalline formations, and completely eradicates the unique aquatic life found within. The destruction may begin miles away on the bright, sunny surface, but the silent, fatal consequences occur deep beneath our feet.
It's a sobering reminder of how interconnected the surface and the deep truly are. We can't treat the underground as an out-of-sight dumping ground without destroying something ancient. To really grasp the incredible diversity and the extremes of these environments before we wrap up, we should look at a couple of specific case files. There are places that completely defy expectations and rewrite the rules of what an underground space can be. Take, for example, the Cueva de los Cristales in Mexico, the Cave of the Crystal Giants.
That is a location that truly embodies subterranean awe. Situated deep beneath a mining town in Chihuahua, it holds some of the absolute largest natural crystals ever discovered by humanity. But what makes it so fascinating is the twist in its formation.
It's not like the limestone caves we've been talking about.
Not at all. This was not created by the simple cold dissolution of limestone. It was the product of intense hydrothermal activity.
So it was essentially a geological pressure cooker deep underground. Deep, scalding, hot, mineral-rich water circulated through the bedrock, creating an environment of unimaginable heat and humidity.
We're talking about temperatures reaching 58 degrees Celsius, combined with 100% humidity. Over hundreds of thousands of years, entirely submerged in this hot mineral soup, elements like gypsum slowly dissolved and then perfectly reformed,
building those massive structures in the water.
The result is a forest of giant, blindingly beautiful, sword-like crystals, some of which stretch over 36 feet in length and weigh dozens of tons.
And it's vital to emphasize the extreme, almost lethal danger of this environment to humans. Because our bodies rely on evaporating sweat to cool down, 100% humidity at 58 degrees Celsius means you absolutely cannot regulate your temperature.
An environment will simply cook you.
It's a deadly space that can only be explored for a few brief minutes at a time, even with specialized ice-cooled suits. It's a stunning but entirely hostile natural treasure.
It's a place where human biology simply does not belong, and the Earth makes that very clear. But if we move from the hydrothermal extremes of the crystal caves to another remarkable system in Mexico, we find a different kind of record holder, Sistema Sac Acton.
Located beneath the Yucatan Peninsula, this is a vast, bewildering network of flooded tunnels. It holds the title for the longest known underwater cave system in the world. But the most frightening and fascinating secret it holds is that it wasn't always underwater.
This brings us back to the concept of deep time and climate cycles. During the last ice age, massive amounts of the Earth's water were locked up in immense continental glaciers. Because of this, global sea levels were drastically lower than they are today.
So the caves were above the waterline.
Right. During that epoch, these vast subterranean tunnels were entirely dry. They were accessible from the surface and were actively utilized by the fauna and the people of the time.
And that is where the discovery becomes almost ghostly. Modern cave divers navigating this dark, flooded labyrinth with heavy breathing apparatus and thin guidelines regularly come across profound evidence of that dry past.
They find incredible things down there.
They find the skeletal remains of mastodons, giant ground sloths, and even ancient human skeletons resting quietly on the cavern floor, perfectly preserved in the silt.
When the Ice Age ended and the glaciers melted, the sea levels rose, flooding the peninsula and slowly sealing the system. The deep, cold, anoxic water acted as a perfect preservative. It transformed the sprawling network from a dry geological wonder into a submerged, frozen time capsule of prehistory, protecting the remains from decay and surface scavengers for millennia.
It's incredibly moving to imagine an early human walking into a dry cavern seeking shelter from a storm, completely unaware that their final resting place would one day be deep underwater, discovered tens of thousands of years later by humans wearing tanks of compressed air. It fundamentally changes how you view the landscape.
It does. It shows us that what we perceive as solid and permanent is, in reality, fluid and fleeting on a geological timescale.
Before we go, think about this. If a cave system can perfectly preserve a mastodon skeleton for 10,000 years, what elements of our modern world are currently washing into these deep anoxic chambers today? In 100,000 years, when the oceans recede again and the deep spaces run dry, what exact footprint of humanity will the next explorers find crystallized in the dark?
A very profound question.
It changes the way you look at the world. The next time you look at a mountain or walk across a limestone ridge, take a moment to remember that you are only ever seeing the shell. The profound, ongoing history of biology, of chemistry, and of deep time itself is playing out right now in the cold, silent darkness beneath your feet.
It is perhaps the ultimate symbol of nature's relentless, quiet power. We're so often drawn to dramatic, noisy events, earthquakes, volcanic eruptions, hurricanes. But the cavern stands as enduring proof that the universe favors persistence over brute strength. It teaches us a humbling lesson in geology, that given enough time, the smallest, gentlest drop of water can tear apart the hardest stone.
It's a deeply grounding thought to leave you with today. We hope you'll take a moment to reflect quietly on the hidden architecture of the world beneath us, and perhaps find a sense of peace in the slow, persistent rhythms of the earth. Thank you for joining us in the dark today. We look forward to exploring another thoughtful topic with you in our next deep dive. Take care.